Hi everyone, so we are on the level 1 of the A.REI.12 standard, and it is all about graphing linear inequalities. Now we have graphed solutions to inequalities before. For example, x is greater than 3. What we did was we graphed this on the number line, we put an open dot at 3, and then we shaded part of the graph. So there's going to be some similarities to what we've done before, but we graphed on the number line when we had one variable. Now we're going to be graphing inequalities in two variables, or they are essentially called linear inequalities. And so we are going to we're going to start off graphing these the same way we would graph a linear equation. So if y is not isolated, we'll solve for y. And then we'll graph using slope and y-intercept, because then our linear inequality would be in slope-intercept form. So we're going to graph how we normally would graph a linear equation. But then we're going to add two more things onto our graph for linear inequalities. Now, linear equations, we just graph and we're done. We draw the line, we're done. But for linear inequalities, we are either going to draw a solid line through the points that we draw on our graph or a dashed line. This is very similar to when we had something like this and we were graphing this on the number line. This is similar to an open dot or a closed dot. So in this situation, we would do an open dot, okay? If we had a greater than or equal to, we would do a closed dot. So this is the same type of thing. Instead, now we're going to determine if we're going to draw a solid or a dashed line on the graph. Now we use a solid line for greater than or equal to or less than or equal to. So if your solution could be equal to the line, then you use a solid line. We use a dashed line for when we have the greater than symbol or the less than symbol, so you don't have an equal to sign. And then when we were doing number lines here, then we shaded part of our number line. We're going to do the same exact thing on a graph. We're going to shade part of our graph. So we're either going to shade above or below our line. There are many ways that you can determine which way to shade. One of the ways is you can test a point, and we'll go through that together. Another way is you can just look at the inequality symbol. If you have a greater than or a greater than or equal to symbol, that would mean you shade above your line. If you have a less than or a less than or equal to symbol, that would mean you would shade below your line. So let's get started. Numbers 1 and 2 are already in slope-intercept form, so we do not need to solve for y. What we're going to do with number 1 is we're going to graph using the y-intercept and the slope. My y-intercept is 3, so I plot a point there. And my slope is -2, which means I go down 2 and over 1, or I could have went up 2 and over -1. Now, before we just automatically draw our line like we're used to with equations, with inequalities, your line could be dashed or solid. If your inequality symbol has an equal to sign within it, then that means you will have a solid line. So for this one, we will have a solid line. And now we're not done, because remember, with inequalities, your solutions can be anything less than that line in this situation, because we have the less than symbol. So there's many ways that you can determine which way to shade. One of the ways is if you have a less than or a less than or equal to symbol, up here it says to shade below your line. So below your line would be in this region here. That's one way to determine a solution. Another way that you could have determined which way to shade is you could have tested a point. For example, maybe you tested or you chose, and this is, you get to choose the point. as long as it's not on the line. Maybe you chose the point 3, 1, this yellow point right here. And the x value is 3, well, the y value is 1, so you put 1 in for y and 3 in for x. And so I have a 1 is less than or equal to a negative 6 plus a 3, or a 1 is less than or equal to a negative 3. And since this is not a true statement, what that would mean is that this yellow point is not a solution, so we should not be shading on this side of my red line. Instead, we should shade on the opposite side, okay? Or maybe to figure out where to shade, you decided to test the point 0, 0. You put 0 in for y, 0 in for x. And you wind up with 0 is less than or equal to 3, which is a true statement. That would mean that 0, 0 is a solution, and that would mean that you want to shade on the same side of the line as the point 0, 0, because 0, 0 was a solution. So we still get the pink shaded region regardless of if we tested a point on the side that was not a solution, part of the solution, or if we tested a point that was on the side that was part of your solution. So you can either test a point like how we did in the yellow and the red, or you could have just looked at the inequality symbol to see which way to shade. It's up to you. All right, number 2, we'll get to 1B in a second. Number 2, we're going to first start off graphing my y-intercept, which is negative 5, and my slope, which is 3/5, which means I have a rise of 3, so I go up 3 and over 1, 2, 3, 4, 5. Or I could have went down 3 and over 1, 2, 3, 4, 5. Another way that you could write this slope, which you might need on the test, come test time, is instead of using the 3 as your rise and the 5 as your run, you can also put this over 1 and do a 3/5 as your rise and a 1 as your run. It might be more difficult with the 3/5 as your rise, but maybe what if your slope was 1/2? You can always write 1/2 over 1 as well to do your slope if need be, and that might come into handy when we're doing systems of inequalities. All right, before we automatically just draw our line, we are going to determine should I have a solid or a dotted line. Since there is no equal to sign in my inequality symbol, that means that I'm going to have a dotted line. What this means is that all the solutions that are on the line, all the points that are on the line, are not actually solutions to your inequality. All right, so you can either test a point, maybe you decided to test the point 0, 0. So if I put 0 in for y, and 0 in for x, I get 0 is less than negative 5, which is not a true statement. So since 0, 0 did not work out, that means that it is not a solution. And so we want to shade on the other side of the line. We don't want to shade towards the 0, 0 because 0, 0 turned out not to be a solution. That's one way that you could have shaded, or you could have noticed that your inequality symbol is a less than, and a less than symbol means we shade below our line, like we did here. All right, 1B. We want to determine, is 1, 1 a solution to this inequality? Now there's 2 different ways that you can do this. You can look at the graph. The point 1, 1 is this point here. And since it lies on a solid line, then yes, it is a solution. That's one way you could have done it. Another way you could have checked is 1, 1 is an x and a y value. So you can substitute that x and y value back into your original inequality. For example, I put 1 in for y and 1 in for x. and we determine if we come out with to be a true statement. I would wind up with 1 is greater than less than or equal to a -2 plus a 3, which comes out to be a 1. So is 1 less than or equal to 1? Yes, it is. So it is a solution. So letter 2B, same thing. You can either look at your graph. The 0.5 -2 lies on the line, but since it is a dotted line, that means that it is not a solution. Or if you were unsure, you could have put 5 in for x and -2 in for y. And in this situation, you would wind up with a -2 is less than a 3 minus a 5, which is a -2 less than a -2. No, it is not. No, it's not a solution. So either way, you can determine if it's a solution by either looking at the graph or putting the point into your inequality. All right, we're going to move on. All right, so recall from the linear equations unit that if you just have y is equal to a number, then this is a horizontal line on the graph. In this case, the horizontal line will cross the y-axis at -4, and it's going to be a dashed line since we have no equal to part in my inequality symbol. You can either test a point, or since it's a greater than symbol, that means that your solution lies above this dotted line. So we shade above. And you don't have to completely shade it in, just kind of roughly shade. All right, looking at number 4, this time I have x is equal to a number. So if y is equal to a number is a horizontal line, then x is equal to a number would be a vertical line. This would be a dotted line, and it's going to go through -5 on the x-axis. Now I have x is less than. Less than means I shade below, which in fact is towards the left of a vertical line. So like this. And you could have tested a point to check. But these are your two graphs for that one. All right, next two, this time we need to solve for y. So in number 5, part A, I'm going to subtract 2 from both sides. I have a -y is greater than or equal to a -x plus a 2. Now this next part, listen very carefully. Remember, when I divide both sides by a negative in an inequality, I need to flip my inequality symbol and I wind up with the following equation. My y-intercept, inequality. My y-intercept is a -2, my slope is a 1, which means I go up 1 and over 1 or down 1 and over -1. This should be a solid line on the graph because there's an equal to sign within your inequality. And since it's a less than symbol now, that means I shade below. Let's do part B. We want to determine if 1,4 is a solution. Well, 1,4 does not lie within the shaded region, so no, it is not a solution. Now we want to provide a solution to the inequality. For this one, you can either give me a point on the line, since it's a solid line, or you can give me a point in the shaded region. It does not matter. So maybe you want to choose this point here, which is the 0.40. That would work. If you chose a different point from me, as long as it was in the shaded region or on the line, then it would be considered a correct solution. All right, I'm going to have you solve for y in 6a by pausing the video, then resuming. Okay, hopefully you got this equation. So my y-intercept is 5, my slope's 5/3, so I go up 5 and over 3, or I could go down 5 and over -3. There would be a solid line, and since it's a greater than or equal to symbol, I shade above this line. Now, is -3, 1 a solution? Yes, it is, because it's in the shaded region. I want you to come up with another solution.